All right, Math 30-2. Well, I can't be there in person today, so I thought it would help if I made a video of the lesson. I'll do a quick run through some of the things that we did yesterday in class and then tie it to what we're doing next. So we've just started a new unit on rational expressions and equations. Yesterday we spent most of the day looking at factoring and how to factor. And then today we're going to take a look at non-permissible values. And so the first thing we did is we took a look at how to factor with a GCF. So I'm going to take a look at an example that we had yesterday. So for example number 4, when I'm talking about factoring with the GCF, I call it the GCF and the leftovers. So what we're doing is we're always looking for a common factor that goes into each of our terms. When our first term is negative, we always want to divide by a negative. And if you're looking for where to start with your smallest number. So 8 is smaller than 12. I ask myself, can 8 go into 12? The answer is no. So the next biggest factor of 8 would be 4. I can pull out a 4. So I'm going to divide both of my terms by a negative 4, again, because my first term is negative. And then I look at the smallest values of n is n. So I'm going to divide by n for both. So my GCF is the negative 4n. The leftovers is what goes in the brackets. So negative 8 divided by negative 4 is 2. N squared over n is n. And then we've got plus 3. So negative 12 divided by negative 4 is positive 3. We can always check to see if we're right by subbing everything back in or multiplying. Maybe a better way to say that is to multiply everything out. So we're going to have negative 4n times 2n, negative 8n squared, and then negative 4n times 3 is negative 12n. So if you multiply everything back out and it takes you back to your original, you're probably right. GCF should always be our first step anytime we're factoring, and that's no matter what type of factoring we're seeing. So always start with GCF and then go from there. The next type we looked at was difference of squares. So when we're looking at a difference of squares, the key word there is difference. That means there's some subtracting. And the squares means that both terms are perfectly squared. So p squared minus 25, we would set up our two brackets. The square root of p squared is p. That goes in the front of each bracket. The square root of 25 is 5. And then plus minus or minus plus. So we're having to have opposite signs because our middle terms will cancel. Again, I'm going through this part fairly quickly because we've done these yesterday. When it comes to factoring trinomials, if there is just a 1 in front of the x squared, then we're looking at for a product of c and a sum of b. So when I'm factoring 2m cubed plus 8m squared minus 64m, first step is to pull out our common factor. So we pull out a 2m. Again, you can divide each term by that 2m if that helps. 2 divided by 2 is 1, so we're left with m squared plus 4m minus 32. The 2m will follow us down all the time. When I want to find the factors of, or when I want to find two numbers that multiply to be 32 and add to be 4, I might want to list my factors. So 1 and 32, 2 and 16, 4 and 8, and so on. Well, the numbers that are going to have a sum or difference of 4 is 4 and 8. If my last term has a negative sign, that means that my factors will have opposite signs. If it's positive, that means they're both the same sign. So I want two numbers that have opposite signs and have a sum or difference of 4. Since it's a positive 4, 4 will be negative and 8 will be positive. So my factors will be m plus 8 and m minus 4. Again, you can check your work by multiplying it back out. Then we got into decomposition and guess and check. And so I'll take you through a couple examples here just as a refresher. If I want to factor 3x squared minus 5x minus 12, if I'm using guess and check, what I want to do is list all my factors of 3. So 1 and 3, that's my only choice, and 12. 1 and 12, 2 and 6, 3 and 4. Guess and check means that I'm going back and forth between my numbers until I find a combination of numbers that have a product of 12 and a sum of 5. And so I'm writing down the 1 and the 3, so it's going to be 1x and 3x. I may want to write these out as crosses first, so I might have 1 and 3, and let's try 2 and 6. So this would give me 6 and 6. That will not get me to a 5. So I might try 1 and 3 and 6 and 2. 18 and 2, that doesn't work. 1 and 3 and 3 and 4. That has a 9 and a 4. 9 and a 4 will get me to a 5. So I'm going to try that one here. So I've got 1x and 3x, and that's going to give me 3 and 4. When I multiply that out, x times 4 is 4x. 3x times 3 is 9x. If I want a negative 5, and they have to have opposite signs, I want a negative 9 and a positive 4. Those translate over, so x minus 3 and 3x plus 4 are my factors. So x minus 3, 3x plus 4. So we'll take a look at this bottom one for decomposition. So the first thing I'm going to do is always look for a GCF. I can pull a 2 out of each of these terms. So my GCF would be 2. My leftovers would be 7x squared minus 9x plus 2. For decomposition, I'm looking at numbers that have a product of the product of those two coefficients. So for 7 times 2 is 14. So my factors of 14, 1 and 14, 2 and 7, and those would be all I have. I want a sum or difference of negative 9, so that would be negative 2 and 7. So I keep that 2. It's going to follow me along all the way. I want to decompose that middle term. So this is going to be 7x squared minus 2x minus 7x plus 2. Again, order doesn't matter. Your instinct may have been to put the 7 first and then the 2 second. Probably my instinct too. I just went a different way today. It does not matter. You're still going to get the same answers in the end. So our next step is then to bracket our middle terms. So the first terms and the last terms, and put a plus sign in between. And then we do common factoring. So we're going to have 2, and then we're going to pull out an x. That'll leave me with 7x minus 2. We're going to pull out a negative 1, and that's going to leave me with 7x minus 2. And my final answer, my factors will be 2 times 7x minus 2 times x minus 1. So again, that's just a really quick refresher on factoring. If you're needing more practice, you can always go back and check these again or work through some of the ones in the practice questions. All right, so we're going to move on to the new part today, and that's non-permissible values, or as you're going to see me write it most of the time, NPVs. So first of all, we got to talk about rational expressions. This entire unit is called rational expressions and equations. Difference between an expression and an equation. Expressions, no equal sign. We just simplify expressions. Equation, equal sign. We're actually going to solve for a value of x. All right, so a rational expression is a fraction that is written as a quotient of two polynomials. So in grade 8, you started working with rational numbers, i.e. fractions. Now we're working with rational expressions. So these are still fractions, but there's variables involved. Now, whenever we're dividing with a fraction, or we have a variable in the denominator, we have to consider restrictions. When we are dividing on our calculator, one number that we cannot divide by is 0, because that's undefined. Okay? And so because we're going to have variables in the denominator, we're going to have to deal with that restriction. So first of all, let's take a look at some examples and non-examples of of rational expressions. So first one here, we've got 6d over 3d squared. It's a fraction, and there is a variable in the denominator, rational expression. Next one, we've got fractions, variable in the denominator, rational expression. This one has a restriction. M cannot be 0. This other one also had a restriction. D cannot be 0. Because if I multiply 0 squared by 35, I'm going to get 0. Makes it undefined. These are not examples, or they're non-examples of rational expressions. When we're working with rational expressions, you will not see an x under the root sign. You will not see a fractional exponent. Okay, so even though there's a variable in the denominator, it is not a rational expression. And again, as I've written here a few times, or I've mentioned a few times, We can't divide by 0. It makes the denominator undefined, so we have to consider something called restrictions. And those restrictions are called NPVs, or non-permissible values. If I was to take 2x over x minus 4 and sub in 4, I'd have 2 times 4 all over 4 times 4 minus 4. Gives me 8 over 0. Doesn't work. Calculator is going to tell me it's undefined. Now, I won't go through plugging the rest of these in, but you could do the exact same thing. When we sub in a negative 2 for m plus 2, we're going to get a 0 in the denominator. Doesn't work. If I sub in 1/2 for 2y minus 1, I'm going to get a 0 in the denominator, undefined. And then the same thing here. B equals 0, sub in the 0 for 2b squared, I'm going to get something that's undefined. So in all cases, these have values that would form restrictions. So when we're talking about non-permissible values, we do not care about the numerator. There will be an exception to that down the road, but for the most part, unless we're dividing rational expressions, we do not care about the numerator. So here I've got 12 over x. I could have 5,672 over x. The restriction would be the same. The numerator doesn't mean anything. So I'm looking at my denominator and I'm saying this cannot be equal to 0. So I literally take whatever's in the denominator and say it can't equal 0. In this case, my answer is already there. X can't be 0. For the next one here, we've got x plus 8. So I take that expression and I say x plus 8 cannot equal 0. I solve for x by subtracting 8 on both sides. X cannot equal negative 8. Sometimes we're going to have things already in factored form. That means we're going to have 2 restrictions. We set each of these individually equal to 0. So we're going to have x minus 1 cannot equal 0, x cannot equal 1, and x plus 4 cannot equal 0, so x cannot equal negative 4. So again, we can have more than one restriction. For D, again, I'm going to take each of these terms or each of these factors and individually set them equal to 0. So x cannot equal 0 and x minus 5 cannot equal 0. And when I solve for x, I'll have x cannot equal 5. Now you may be saying, well, you say set them equal to 0, but you're setting them not equal to 0. There is a little bit of semantics involved. If you were asked for a restriction would be that x can't be 0 or x can't be negative 8. If you're asked for the non-permissible value, you would say the NPVs are x equals 0 or x equals negative 8. I am not going to get too picky about whether you wrote it as a restriction or wrote it as an NPV. Doesn't really matter to me. It's not something you need to worry about too much on an exam. Other than you just have to know how to do the restrictions. But don't worry about the semantics of restriction versus NPV. If you're someone who has trouble with that not equal to sign, just write equal to, solve it, and then go back and put your slashes in. So for example, for D, you might have said x equals 0 and x minus 5 equals 0, x minus x equals 5. And then if you want to write them as restrictions, you can always go back and put your little slashes through. All right, so for E, F, G, and H, we have to look first at factoring. Not everything's going to be written in factored form for us. Most of them are pretty nice. They're usually going to be GCF questions like common factoring or difference of squares. You're not going to have a lot of heavy factoring with these. All right, so we've got 4x squared minus 4x. First thing you're going to do, pull out a GCF, pull out a 4, pull out an x, and that's going to leave me with x minus 1. That cannot be equal to 0, so that means x cannot be 0, and x minus 1 cannot be 0, which means x cannot be 1. So there are 2 restrictions. I am not going to be expecting you to show me every single step. If you can look at x minus 1 and know that the restriction is 1, then you're golden. You do not have to show me every step, just that you have your restrictions. All right, for the next one here, we would pull out a y, and that's going to leave me with 3y minus 1. All of that cannot equal 0. So y cannot equal 0, and 3y minus 1 cannot equal 0, and that means y cannot be 1 over 3. So again, I said you don't have to show your work. So if you're trying to do the algebra in your head, think step by step what you would be doing to solve for y. A lot of my students will say that they know that y can't be 0 because y is on its own. So if you just have a y here not being multiplied or added or subtracted to anything, then it's like saying y can't be 0. Because if this were 0 and it got multiplied by anything else, it would make the whole expression 0. So a number of my students will say y is on its own, therefore y can't be 0. If that's a way to help you remember it, then by all means go for it. For 3y minus 1, if I'm thinking the algebra in my head, I'm going add 1, divide by 3. So 1 first, then divide by 3. Okay, so we'll take a look at this one. We've got a squared minus 25. That's a difference of squares. Remember, whenever you have two terms, there's only two options. It's either common factoring or it's difference of squares. This one has two terms, a subtraction sign, and both terms are perfect squares. So it's going to be difference of squares. A plus 5, a minus 5, all cannot equal 0. And so that means a cannot equal plus or minus 5. The last one here is one that will often throw a bit of a curveball to people. Not everything will have an NPV. So if I pull out a 3 here, because that would be my first step when I'm factoring, I'm left with p squared plus 3. Now you've got a couple options. One, you can use logic and say, wait a minute, there is no number, even if it's like negative a million, that I can square and add another number to it and get to a 0. Because no matter what number I put in, as soon as I square it, it becomes positive. If I'm adding a 3, it's just getting bigger. That's one way to go about doing it. Another way is to just do what we've been doing, set it equal to 0. P squared cannot equal negative 3. I square root. I can't square root a negative, so I know that this restriction doesn't work. So if there are no restrictions, you can just write NR, or no restrictions. All right, so I can't stress this enough. When we're working with NPVs, almost always we're going to have to factor. So we're going to take a look at one more example here, and this is just more of a theory-based example related to your NPVs. What I want you to get from this lesson is that your non-permissible values are simply a restriction. You're finding out the values that would make the denominator equal 0. That's all we're doing today is we're just checking for NPVs. We're going to be using NPVs for the rest of the unit. So it's a really important concept you want to make sure you have an understanding of. All right, so it says in each case, write a rational expression with the given variable and NPV. So we want something with a variable of x and an NPV of 1/4. So we can write this as x cannot be 1/4, and then we just rearrange until your expression is equal to 0. So the first thing we would do is multiply by 4. So we got 4x can't equal 1. Subtracting 1 from both sides, we have 4x minus 1 cannot equal 0. That is our denominator. Our denominator would be 4x minus 1, if that's our NPV. What you put on top doesn't matter. 2x plus 5, x squared, 4, it doesn't matter. You could have a ton of different answers. You could even have something like this. 3x, let's do this, 8x all over 8x minus 2, or 6x over 8x minus 2. If I were to simplify that down, I would still have 4x minus 1 in the denominator, so this would work. For the last one here, it says non-permissible values are 0 and 7. So this time we have to have two values. So I know that if x can't be 0, then I've got x standing on its own. And if x is equal to 7, the factor will be the opposite sign. So it's going to be x minus 7. Again, whatever you put on the top, you can even put smiley face. Not that that's really a rational expression, but put a smiley face. Or maybe I'm going to put, I don't know, 12 all over x times x minus 7. That's still going to be an expression that has those NPVs. All right, guys, so this is intended to be a fairly short lesson. The goal is for you to get as much practice as you possibly can. I will have Mrs. Leung give you the assignment for today, and you have the rest of the period to work through these questions, ask for help as you need to, and I will be back tomorrow. Have a great day, guys. See you tomorrow.